In this video we describe the working principle of fan cooling towers. The cooling tower is a device for cooling large quantities of water, which circulating in a water recycling system. Circulating water system is a system in which water is used as the refrigerant for cooling the heat exchange equipment. The use of cooling towers saves natural water from 25 to 50 times compared with once through cooling, and prevents thermal pollution of water bodies. After cooling, the main volume of recycled water fed back into the process cycle. Usually no more than 5% of water is lost to evaporation, drip loss, leakage, and discharge into a blow-down system. Losses are replenished by fresh water makeup. So, how is the cooling tower working? Water in cooling towers is cooling by evaporation of water in the stream of atmospheric air, the heat transfer by contact with air. Hot water from the various sources such as machines or heating processes flows through pipes to the distribution system of cooling tower, which produces even water distribution to all the area of fills by the spray nozzles. On the fills the water film is formed from the surface of which evaporation of the water and encounter airflow. Then larger the surface area of the fills, the more intensive is the evaporation of water, and the more efficient is cooling tower. Evaporation is accompanied by expenditure of energy required to convert liquid to vapor. Humidity of the air is increasing when water evaporating. With the help of the fan is fed a steady airflow with low humidity. The air passes through the fills, saturated with water vapor. The water cooling efficiency of the fan cooling towers may be controlled by varying the supply air fans, changing of fan speed. As theoretically ideal, loss on work to convert the water to steam. The limit of the cooling water in the cooling tower is the temperature of the outside air wet bulb temperature. In practice, the limit of cooling is the temperature of the humid thermometer of +3 degrees Celsius. Operating a cooling tower emits air saturated with water vapor and containing water droplets with size of 100-500 micron. To prevent entrainment of water droplets above the water distribution system is installed a drift eliminator. Cooling water moves down and flows into a catchment tank, and then the pump is supplied to the technology.